Hello everyone, my name is Sagar Dhotare. Uh, we have already discussing about the theory of sliding contact bearing. Also, we have seen simple numerical on sliding contact bearing. So, in today's lecture, we will discuss more two numericals of sliding contact bearing, but they have some different inputs. So, based on that, we can how we can perform or how we can design a sliding contact bearing. Okay, so let's start with the numerical. A full journal bearing is used for supporting a load of 7 kilonewton at 500 rpm for a machine tool application. Selecting feet of hg, eg, and L by D ratio of 1. What we need to find out: first, bearing dimensions; second, sommerfeld number; third, minimum oil film thickness; fourth, coefficient of friction; and fifth, last one, is a temperature rise. So procedure uh, with respect to the previous numerical, the procedure was the same, but few changes are here. Okay, let's start with the note down the given from the problem. Load 7,000 Newton, that is 7 kilonewton. We need speed in RPS while calculating the sommerfeld number. So we have converted speed into RPS, that is 8.33 RPS. Given L by D ratio is 1. Okay, so first step, find out the dimensions of bearing, that is a diameter and length. So we have an application, machine tool application. So based on this, we need to first upon find out the uh, bearing pressure. As we know, we are referring PhD page number 7.31. Based on the application, we always find the bearing pressure if it is not given. Okay, here the bearing pressure is given, that is a 21 kg per cm square for particular machine tool application. So we have converted it in Newton per mm square. So what we get? We get a direct value. Bearing pressure is equal to 2.1 Newton per mm square. Now, using same formula, bearing pressure is equal to load by projected area. We need to calculate diameter or length. So putting all the values, that is P is equal to 2.1, W is equal to 7,000, and L is equal to D. So D square is there. After the calculation, what we get, D is equal to 57.73, which is we can modify it to 58 mm. Now the diameter is equal to 58 mm, length is equal to 58 mm, as L by D ratio is equal to 1. Next one, as the ratio changes, what do you say, the length which is calculated was 57.73. Okay, so जैसे ही length हमने modify किया तो actual bearing pressure get modified. Now we are going to find out the actual bearing pressure. So putting all the values, that is W, L and D, the bearing pressure which we get is 2.08 Newton per mm square. Okay, हमने जो select किया था वो 2.1 था, but in actual practices it is 2.08 Newton per mm square. Now next one, find out the clearance value, that is a diametric clearance. Now for find out the diametric clearance, they have provided the type of feet, that is a clearance feet, that we know that HG, EG is given. So in PSG, referring PSG page number 3.9, So referring PhD page number 3.9, we can find out the value which we needed. Okay, so here the table is given, where it is called as a tolerance table. So in this tolerance table, based on the diameter, that is a diameter of 58. So based on this, we need to find out the exact values for that. So here for 8, uh, wait a minute, for 3.9, 3.9, sorry, 3.9, PhD page number 3.9, the fit is H9. Okay, so here the H9 fit is given. Okay, so for H9 feet, the range is provided over here. Okay, so 50 to 80, the range is given, that is a plus 74 micron to 00. Okay, so the minimum tolerance we can use is 00, and the maximum tolerance we can add, that is a 74. And similarly for G9, that is referring PhD page number 3.7. So here also they have provided the values are 0.0, wait a minute. So here also they have provided value for E9, sorry, that is E9. Okay, so for E9 it is minus 0.06 and minus 0.0, that is 60 micron, and maximum value is 134 micron. So in between this range, you can reduce the values. Okay, so we have written these values by using minus 60, and by mistakenly I have written over here minus 112. Okay, so you can make a change on this of this. Now go to the design. So based on this value, you just make sure here the diameter should be 58. By mistakenly I have written over minus, that is a 70 H9 and 70 E9. Okay, so it should be diameter of 50 G9 H9 and 58 H9 and 58 E9. Okay, so by referring this tolerance table, we have note down the tolerance values. Okay, now based on this tolerance table, we need to find out the actual or average diameter of bearing as well as journal. Okay, so the diameter DA I have mentioned as the diameter of journal. So a bearing, that is a maximum one. So 58 plus 58 plus, that is 0.074 plus 0.00 divided by 2. So what we get? So diameter of bearing is equal to 58.037 mm, and diameter of journal should be lesser than that. So here 58 minus 0.060 plus 0.112 divided by 2. So what we get? 57.914. So when we get a difference between these two diameters, what we get? We can directly find out the diametric clearance. Okay, so I request all of you just properly select the tolerances from the tolerance chart which is provided to you. Okay, from PhD page number 3.7 and 3.9. So here what we find out, the diametrical clearance, that is C is equal to 0.123. Okay, now next one is find out the absolute viscosity for oil. As we know that from PhD page number 7.34, the equation for absolute viscosity is Z dash is equal to Z divided by 9.81 into 10 raised to 7. So for machine tool application, the value of Z is 40. Just we can take a glance. So from here For machine tool application, the value of Z is 40. Okay, so this value we have used for calculation purpose. Okay, look at here. For machine tool application, the value is given. Okay, the value is given is 40. For value of Z is equal to 40. Okay, now we are using this value for our further calculations. So putting all the values, what we get? We get Z dash, that is the absolute viscosity of oil, is equal to 4.077 into 10 raised to minus 7 Newton second per mm square. Okay. Now next one, to find out the sommerfeld number, we are using same process which we have already discussed in a previous numerical, but here we have selected sommerfeld equation from PhD page number 7.34. S is equal to Z dash N dash divided by bearing pressure P D by C bracket square. So putting all the values, what we get? The value of S is equal to 0.363. Now we need to refer PhD page number 7.36 to find out the dimensional parameters. As the journal bearing is a full journal bearing, so we need to find out the table for full journal bearing. As D by D ratio, L by D ratio is 1, so we have to refer this block only. Okay, we need to use this block only. Now next, as the value of L by D is equal to 1, now we need to find out the value of sommerfeld number. The sommerfeld value is 0.363. Okay, so this is the sommerfeld number. Okay, so this sommerfeld number value is now lies in between two different values. Okay, so it is lies in between 0.264 and 0.631. Okay, now we need to find out the actual value of other dimensional parameters. How we can find out? By using interpolation method. So we are using interpolation method to find out all the values related to remaining parameters, that is a dimensional parameters. Okay, so here I have make a sample calculation for interpolation method. So we need to calculate, as we the value of S is lies between 0.264 and 0.63. So I have prepared one interpolation calculation to calculating the dimensional parameter of 2H0 by C. The value for 0.264 is 0.6, and for 0.264, the value of H0 by parameter, just a minute, we will check here. Okay, so for calculating the values, we need to value of same parameters. ठीक है, so यहाँ पे sommerfeld का जो value है maximum value, that is a 0.631, और 2H0 by C का value है maximum is 0.8. Lower value of sommerfeld number is 0.264, and similarly for 2H0 by C it is 0.6. So these values we have considered for interpolation. Okay, so now let's check the calculations. Okay, so 0.631 minus 0.363 divided by 0.363 minus 0.363 264. Okay, as we don't have a value of twice h0 by c, I have considered as a x variable. So 0.8 minus x divided by x minus 0.6. After the solving this equation, what we get, the value of x is equal to 0.63. Now similar method I am using for calculating the all the values of remaining dimensional less parameters. So here I have mentioned that I have make a table for calculated values. Then attitude ratio is equal to 0.254. Mu d by c is equal to 7.7. 4q divided by dc and dash l is equal to 3.699. qs by q is equal to 0.33. Rho c dash delta t divided by bearing pressure is equal to 31.91, and the ratio of P divided by P max is equal to 0.496. Okay, now we are using first one, that is 2H0 by C, to calculate the minimum oil film thickness. Okay, so here 2H0 by C is equal to 0.653. Putting the value of C, that is a 0.123, what we get, that is a minimum oil film thickness is equal to 0.0401 mm. Next one, we need to calculate the coefficient of friction. Similarly, we have selected the dimensional less parameter mu dc d by c is equal to 7.7. Putting all the values, and what we get, the coefficient of friction is equal to 0.016. Now we need to calculate the temperature rise. Now here very simple, just we have to select the dimensional parameter, that is rho c dash delta t0 divided by bearing pressure is equal to 31.90. As we know that the rho c dash is equal to 14.2 Newton per mm square degree centigrade, and the value of bearing pressure, actual bearing pressure, is 2.08. Putting both values in equation, what we get, the temperature rise, that is a maximum temperature rise, is equal to 4.69 degrees centigrade. So we calculated all the parameters, or whichever the required from the problem that we have calculated. So I hope this is a very simple method and you can follow this method. So it is very easy to calculate the dimension and what you can say, design variable as well as performance variable through this method. Let's go with the another example. Second example, here some parameters are more changed as compared to the previous one. A journal bearing of 50 mm diameter and 80 mm long has a bearing pressure of 6 Newton mm square. The speed of journal is 1000 rpm, while the ratio of journal and diameter clearance is 1000. The bearing is lubricated with the oil. Those are absolute viscosity at operating temperature of 75 degree at 0.015 kg meter per meter second. If the room temperature is 25 degree, determine the amount of artificial cooling is required. Second, the mass of oil is required. If the difference between outlet and inlet temperature is 10 degrees centigrade, also calculate the discharge. At the specific heat of oil is 1900 joule per kg degree centigrade, and the heat dissipation coefficient is 50 W per meter square degree centigrade. Okay, so in this problem lots of data is given. Okay, now in such cases we can directly use a numerical relation, or you can say formulas, or you can refer similar method which we have used in a previous method, previous problems. So let's check how we can solve this problem. So first of all, write down the given parameters. First parameter, diameter, that is a 50 mm, length 80 mm, then bearing pressure 6 Newton per mm square. Speed in RPS we have converted, that is 16.667 RPS. Z value, absolute viscosity, that is 0.015 Newton second per meter square. Then temperature, living temperature is 75 degree. Input temperature, or you can say atmospheric temperature, is 25 degrees centigrade. Then D by C ratio, which is given, is 1000. Value of Cp is 1.9 kilojoule per kg degree centigrade, and the value of C is equal to 50 W meter square degree centigrade. Okay, so let's start with the first step, calculating the load on bearing. As the diameter and length is given, bearing pressure is given, so first of all find out the load. Okay, so putting using same equation, P is equal to, that is the bearing pressure is equal to load divided by area. Putting all the values of bearing pressure, diameter and length, what we get? We get a load is equal to 24 kilonewton. Okay, now next one, calculate the L by D ratio. So L by D ratio is equal to 1.6. Now here, if you referring the PSG, what we get? They have provided the value of L by D ratio for 0.25, 0.5, then 1 and infinity. Now, in this condition, L by D ratio is equal to 1.6, okay, which lies in this category. So that is the infinity category, okay. So whenever you are using L by D ratio greater than 1, the values are lies in this category. Now go to calculation for sommerfeld number. Using same equation with PSG page number 7.34, S is equal to absolute viscosity into the journal speed divided by bearing pressure, then diameter divided by diametric clearance bracket square. So all the values are given. So D by C ratio is given, that is 1000. Putting all the values, what we get? The sommerfeld number S is equal to 0.04166. Okay, so here you can refer both way. There are two ways. First way, which we are using in a previous solution also, that is referring the table with the dimensionless parameters, finding the standard values and putting and calculating. Okay, so that one is one method. Second method is you can use empirical relations. Okay, so in this problem we are using empirical relations. Now to calculate the value of mu, you can use a Petrov's equation. As we already discussed, Petrov was the first scientist who have conducted lots of experimental data over the coefficient of friction. Okay, so that equation is given in a PSG. Referring PSG page number 7.34. Here two scientists are provide the equation for Mac's equation and Petrov's equation are provided. If the values or you can say the load on bearing is very less as compared to the value of S. Now the value of S which is lesser than that of 0.15, as we have calculated the value of S is 0.04166. तो हमें ये equation, अगर लाइट लोड है तो मैकेज इक्वेशन ले लो, अगर एस का वैल्यू ग्रेटर देन और यू कैन से फॉर ग्रेटर देन रहेगा तो आप लोग दूसरा इक्वेशन यूज कर सकते हो, या फिर थर्ड वन इक्वेशन also given in PhD. Okay, so you can refer this one is also. Now I have considered a Petrov's equation. Okay, so mu is equal to 2 pi square z dash n dash divided by p rest into d by c. Okay, so in this condition all values are with us, so it is very easy to calculate the value of mu. So putting the value of z dash n dash, bearing pressure, diameter and diametric clearance, what we get, the value of mu is equal to 8.22 into 10 raised to minus 4. Now next we need to calculate the power loss in the friction, because this is used this value is required to calculate the whatever the amount of heat dissipated and generated. Okay, if heat is dissipated very less, then we have to use external artificial cooling requirement. If it is not, then it doesn't require. So for confirming the requirement of artificial cooling, we need the heat generated and heat dissipated. So while calculating the power loss, the equation is given Pf is equal to 2 pi n dash mu into W divided by mu into W into R divided by 10 raised to 6. So 2 pi into n dash, that is 16.667, then mu 8.22 into 10 raised to minus 4, W 24,000 and R, that is 25 divided by 10 raised to 6. So what we get, the power loss due to the friction or power loss in friction, Pf is equal to 0.0818 kilowatt. Now next one, as I discussed, as I said, the rate of heat generation is very necessary. That मतलब कैसा है कि जैसे ही फ्रिक्शन होता है तो फ्रिक्शन से हीट बढ़ जाता है और वो हीट ऑयल पूरा कैरी करना चाहिए, otherwise the viscosity get reduced and the oil film thickness, that is a minimum film thickness which is breaked and directly metal to metal contact may be occurred. तो ये अवॉइड करने के लिए हमें इंश्योर करना पड़ेगा कि हीट प्रॉपरली डिसिपेट हो रहा है कि नहीं हो रहा है। अगर नहीं हो रहा है तो हमें आर्टिफिशियल कूलिंग सिस्टम लेना पड़ेगा। So whatever the heat generated, Hg is equal to the heat generated due to the friction. That is, so it is directly compare and we can find out, or we have converted the value of kilowatt into kilojoule per second. That is Hg is equal to 0.0818 kilojoule per second. Next one, the rate of heat dissipated. अगर हीट जनरेट हो रहा है तो वो कहीं तो भी डिसिपेट होना चाहिए, तो ये भी हमें कैलकुलेशन करना पड़ेगा। तो इसका इक्वेशन है Hd is equal to C into A divided by K plus 1 TL minus TA into 10 raised to minus 3 kilojoule per second. We are considering K is equal to 0.4, area that is a 10 L by D. So what we get, that is a value in meter, 0.04 meter square. Putting all the values, what we get, Hd is equal to 0.0714 kilojoule per second. So if you compare both values, heat generated जो है वो 0.0818 है और heat dissipated है वो 0.0714 है। इसका मतलब कि जो हीट जनरेट होता है वो पूरा डिसिपेट नहीं हो रहा है, तो इसका मतलब है कि हमें एक्सटर्नल कूलिंग रिक्वायर्ड है। अगर सेम हीट अमाउंट ऑफ हीट रिलीज होता तो हमें ये एक्सटर्नल और यू कैन से आर्टिफिशियल कूलिंग रिक्वायर्ड नहीं रहता है. Okay, so it from step number 6 and 7 it indicates that we needed the artificial cooling. Now what amount of artificial cooling is required, that we need to calculate. Okay, so rate of heat generation minus rate of heat dissipation. So the rate or amount of artificial cooling, that is difference between rate of heat generated and rate of heat dissipated. So that after calculating what we get, 0.0104 kilojoule per second. So that much heat should be carried by using artificial cooling. Next one, now we need to calculate what should be the mass or mass of lubricating oil required to carry that much amount of heat. So HR is equal to mcp delta T. HR का वैल्यू पता है, दैट कितना हमें हीट कैरी करना है और यू कैन से एक्सेस हीट जो है वो रिमूव करना है, that is a 1.04 into 10 raised to minus 3 is equal to m into 1.9, that is the value of Cp, into delta T, which is given, that is a 10. Okay, so this equation we are using for second condition. Okay, if you read problem properly, the second condition is given, that is a temperature difference is 10 degree, and now we have to calculate the amount of or mass of lubricating oil. So for this condition we are using this equation, otherwise we have to calculate delta T, that is 75 minus 25, that is a 50. तो ये कंडीशन दूसरी जगह पे हम लोग यूज कर सकते हैं, लेकिन इस जगह पे कंडीशन हमें दिया हुआ है कि टेम्परेचर डिफरेंस जो है वो 10 डिग्री है. ओके, आई होप you have cleared the doubt related delta T. Now putting all the values, what we get, the mass of lubricating oil is equal to 5.473 into 10 raised to minus 4 kg per second, or we can say 0.0328 kg per minute. Okay, so that much mass is required for getting a heat of 0.014 from the system. Now similarly we need to find out the flow rate. अगर इतना मास हमें उतना हीट कैरी करना है तो उसका फ्लो रेट कितना होना चाहिए, मतलब ऑयल का फ्लो रेट कितना होना चाहिए. So with the using simple equation, m divided by rho, rho is considered as 860 kg per meter square, meter cube, which we can previously seen with the problem. ये डेटा हमें पहले भी हमने यूज किया है प्रॉब्लम में, so I'm using same data, that is q is equal rho is equal to 860 kg per meter cube. So putting both value of m and q, small rho, what we get, the discharge rate is equal to 3.813 into 10 raised to minus 5 मीटर क्यूब पर मिनट. तो इतना डिस्चार्ज हो रहा है. अगर ये हम कन्वर्ट करें लीटर पर मिनट में तो डिस्चार्ज होता है Q is equal to 0.03813 liter per minute. Okay, so in last problem what we seen, we can calculate all the values by using simple empirical relations, and in previous two problems we are using the dimensionless parameter table. Okay, now in both way you can calculate and you can find out the all values. Okay, I hope the design procedure of sliding contact bearing has been clear to you, and if you have any doubt related to design of sliding contact, you can anytime call me, or anytime you can message me, or you can email me. Okay, so I hope this both problem and previous problem will explain properly, and you shouldn't have any kind of doubt related to design. Okay, so thank you very much. In next lecture, or we can say in next video, we will discuss the design of cam and follower. Okay, so the next topic is cam and follower. Thank you very much for joining this lecture.